In this video, we're going to take a look at some basic ways that Ruby represents numbers. The first, of course, Ruby can represent integers. So we can have 1, 2, 3. That's a base 10 number. We can have negative integers, negative 1, 2, 3. You can also use the plus sign, it's the same. But you can also represent some different bases. You can have binary, and you start a binary by doing a 0b, and then if I do 101, that should be a decimal 5, and sure enough, there we go, that's 5. You can do octal by preceding a number with 0, so you should be careful using that. So if we do 0, 1, 0, that should be 8 in decimal. So you see it's giving me back the decimal numbers here. We can also do hexadecimal. So if I do 1, 0, that should be 16. Or we can do 0f, which is 15. So you can see you can represent different numbers moving around with those. It works pretty well. You can also do floating point in that way. You can do negatives as well with floating point. So it has pretty good representation of numbers. You can also do basic math. We've seen that in other videos, and it's really pretty funny how fast it is. I've been impressed with its speed, even on large calculations. Let's do something really silly here. Oops, that was really silly. How about that? There you go. Now that's impressive that it has the algorithms built in to spit back that kind of number. And in another video, we're actually going to play around a little bit with an RSA algorithm that relies on these huge numbers, and they're accurate because when you encrypt something, you use these large prime numbers like this and raising them to different powers. And when you decrypt them, of course, if your math isn't right on, your decryption isn't going to work. And it works. And I discovered that earlier this year that Ruby was able to do that. And I'm very impressed with that. We've seen in other videos where you can actually take a string and convert it into a number. So that's pretty sophisticated. Of course, you can assign a sign like that, so we could use that in calculations now if we want. We could round it off if we want. Let's do new pi equals pi dot round, and there we go. We'll redesignate it as 3. So you can have rounding there, and a rounding holds to the typical rules of 5 and greater will go up type of thing. So it has some pretty good basic math abilities. Anything more advanced, you'll have to build algorithms to do that, and we'll actually look at a few things in other videos. If you want to print out numbers, the thing that you have to do with printing is you can use a printf type function if you really want to make them look nice, and then you essentially give well, let's declare something out here and say x equals 2, 3, something like that, and then y equals that. So now if we want to print this in a very specific format, it has this printf, which is very much like the C type of method. And what this does is, this is our method call, so we're printf is a method call. This is the string that's going to get printed out, but what we're doing here is providing some formatting information here. We're saying the f is floating point, and then we're specifying how many digits to the left of the decimal and how many digits to the right of the decimal. So you can see it took our x that we put in here and chopped it off. It doesn't, I'm not sure if it rounds. Let's change this and see if it rounds. So it rounded it up for us, so that's a good thing. Be careful with it if you're expecting to do math with it, and the rounding might lead to unexpected kind of things. To print just a decimal, you would just do the D, and let's put in the Y. That was our decimal, or integer I should say, not decimal. And you can actually put into here if you want and force how many digits to be displayed. So if you need it, some accounting type things, like to have different paddings in there. Let's go up to 6. So you can pad it out with zeros and use the 6 to force it over if you want. So that's basically some formatting and some basic operations and information about numbers in Ruby.